Roots and Zeros in Polynomial Equations by Justin D'Souza. The learning objectives of this lesson are: use fundamental theorem of algebra to determine the numbers and types of roots of polynomial equations. Here it's not only the number, also the type of roots. That's an important thing. Say whether it's imaginary root or real root, positive or negative. And we will also look into determining the numbers and types of roots of polynomial equations, find zeros and use zeros to graph polynomial functions. We will also try and write the equations just from graphs. The keyword is multiplicity. Fundamental theorem of algebra. Now what it says is, whenever you solve a function making it equal to 0, you will find the roots. Now imagine you have a function f of x is equal to x squared plus 3xa plus 2. Now if you equate that equal to 0, but we will consider the x to be any constant, because we know for certain when we equate this to 0 we will have some value. So we will consider that to be c. So it will be c squared plus 3c plus 2 equal to 0. Now we can use mod phi 3 and easily solve this up. You can follow what I'm typing in the calculator from this key logs. So let's go to mod, phi for equations and 3 for quadratics. Now what are the coefficients over here? The coefficients are 1, that's before c squared because there's nothing, it's 1. Then we have, let's press equal to, next one is 3, and then lastly we have 2. So these are all the coefficients. They're just typed out, and now press equal to. You get the first solution, that is x1 is equal to minus 1, and then we have minus 2. So we will use these terms and write it out over here now. C is equal to minus 1, C is equal to minus 2. So these are basically the roots or the solutions. But these are also the zeros. What happens is, now imagine if you graph this, since it's positive x squared, we will have upwards, but the roots are minus, so something like this. Imagine this is minus 1, minus 2. What do these points resemble? What do these points tell us? That these points are basically the points in the graph when it touches the x-axis. So it's zeros. Zeros are x-intercepts basically. So we call them, you can see for this particular equation, it's another equation. These two are the zeros when we solve it and get it, right? They're called the roots, or the solution are also zeros. But the only difference is, zeros means, see in this equation, these both are the zeros. That means it's the x-intercept. And roots is basically by equating, when you solve it, you get the two values. They both are the same thing. They can be used interchangeably as well. And factors. Now you have this as minus 1. So one solution is minus 1. Take it inside. It will be x plus 1. This is one factor. And this negative 2, take it inside. It will be plus 2. So these are the two factors. Over here we have minus and plus. So x is equal to minus 6. Take it inside. It will be x is equal to 6 as one factor. And x is equal to minus 3 plus becomes minus another factor. And the intercepts are basically these points, right? It's minus 2, 0. The y value is 0 at x-intercepts, and over here minus 1 and 0. Here there is another thing, that's the corollary. That's like the opposite. What it says is, depending on the degrees, you can tell how many roots are there for a particular equation. So the degree is the highest power among all the terms. Here we can see that's 5. So that means there are 5 roots. Same way over here you can see the degree is 4, that means 4 roots, and so on. Depending on the highest degree, you can tell the number of roots. And the last thing over here is multiplicity. You might have heard this in the keywords. What exactly does it mean? Now imagine sometimes there will be, a quadratic function which touches like this over here, only at one point at x is equal to 0. The solution is only x is equal to 0. We got the solution only one, x is equal to 0, but we know it's quadratic, x squared, so there must be 2 roots, isn't it? So what happens is, the multiplicity of x is equal to 0 is 2. What it means is, this one over here is 2 times, in the sense x squared is equal to 0, the equation, right? So x is equal to 0, x is equal to 0. So there is 2 multiplicity, or x times x, isn't it? So that is the thing. Now you can see over here x cube. So that is having a multiplicity of 3. Now it might be with other numbers as well. So you might just get the root of -1. So that means at x, see something like, sorry, not over here it will be. So this will be 1. So here exactly at 1 it is touching. So we can say there is a multiplicity of 2. So this is about the multiplicity. And the last concept before problems is Descartes' rule of signs. Descartes, it's pronounced as Descartes, not Descartes. Descartes, René Descartes, I think so, is a French mathematician. Usually their names are like that. So here what he says is, just by looking at the coefficients of the given equation, you can tell what the roots are. We will look into a problem, it's much easier, I'll explain you over there. But this guy found that if you have all the coefficients of all the degree, and there must be no coefficient which is having 0. If you have 0 as the coefficient, you can't use it. If not, if you have all the coefficient, you can easily find how many positive roots and negative roots. And that is what we will solve now. Before that, this is a general problem. We will solve Descartes' rule in the coming problem. Here you can see we have x power 4 plus 49x squared equals 0. So how would you solve it up? Some calculators do solve these problems directly, but most do not. So how would you go about this? You can see there is x squared and x squared. So how about we remove that terms as common term? So but from distributive property, if you remove that outside, you will have x squared remaining here plus 49. That is equal to 0. Since we are equating this and this term to 0, we can separate them as x squared equals 0, x squared plus 49 equals 0. Here we have x is equal to 0 itself, but multiplicity m is 2 over here. Why? Because it is x and x. And what about over here? We will have x squared is equal to negative 49. Square root of negative 49, what is it? It will be, so sorry, x squared is gone because we have taken square root, or you can have x squared and just take the square root. Those both cancel off. Here it will be plus or minus 7i. Now we can try this in the calculator directly from this step. You can use mod 5 and 3 and put in the coefficients. The coefficient is 1 over here, and there is no x term, so it's 0, and then lastly we have 49, and the roots are 7i and minus 7i. So that's plus or minus 7i, because imaginary roots always come in conjugate. So this is how we basically solve the problem. We have three roots, sorry. There is one x is equal to 0, two imaginary numbers, but the x is equal to 0 as a multiplicity of 2. So that is it. Here we can see all the two imaginary roots and one real repeated root is mentioned. Now in the next problem, we will use Descartes' rule to find out the type of roots. We are not exactly finding which are the roots, we're just finding the type of roots. You can see here, it starts with x to the power 5, then 4, 3, 2, 1, and constant term x is 0. All the coefficients are there. Only in such problems we can use it. So it's very simple. What Descartes says is, if you look into the coefficients and see the signs, over here there is positive, right? What about the next term? It's negative. There is one sign change. You can just write it as, yes, there is a sign change over here. And now there is minus and minus. There is no sign change, no. And again, yes, there is sign change because the sign changes from negative to positive. And over here from positive to negative again, yes. And negative to positive, yes. And that's it. So there is sign change by 1, 2, 3, 4 times. That means there will be 4 positive real roots. So this is what it says. Because there was sign changes with the coefficients 4 times. And now this is for the positive real roots. As it is the given equation. But what about negative real roots? Positive real root means it can be, say, 2, 3, 4, any positive number. But what about minus negative numbers? So for that, you have to rearrange and change this equation. So what you need to do is, instead of f of x, you use minus x. That's it. Now here, minus x to the power 5. This is supposed to be the variable x. I just made it worse and worse. Now here again, minus 2x to the power 4. But remember, there is negative. So whatever x is there, right, it becomes minus. That's it. Power, everything is same. Now all the other signs are same. Just put minus x instead of x over here and use a bracket. And over here also it will be minus x the whole squared minus 5 times minus x. Lastly we have plus 10. Now whenever there is even power, your negative sign, what happens? Say minus 2 times power 2. That will be minus 2 times minus 2. The negative cancels off, it dissolves, because when you multiply 2 times negative, it becomes positive, so it will be plus 4. Even if you have any even number, you try this again, 4. There will be another 2 over here, another 2 over here, so it will be positive no matter what. But what if it's an odd number, if you have power 3? So you will have only 1, so this and this cancels off, becomes positive, but again positive, negative becomes negative, right? So whenever there is an odd power, the sign changes here. See, now this is odd, so it will be minus x to the power 5. Whereas for even numbers, this minus x to the power 4 will be positive. So it's just minus 2, this will be positive 4. Now here what happens is basically minus outside, let it be as it is, as it was minus 2. But what happens inside is this will remain negative. So this minus sign has to be multiplied over here, minus x to the power 3. You can write it in terms of brackets, but it's like this. Okay, bracket to the power 3. And then you have over here minus whole square, and that becomes positive. So it'll be just power 2. Minus is gone. And lastly here we will have minus and minus, that will be plus 5x. And last number as it is. Now if you want to check this, you can type out in calculator minus 1, open the brackets, power 5. Here the answer is minus 1. Or if you put 7, 3, 9, any odd powers. Whereas if you put an even number as the power 2, 4, 6, 8 or anything, you will have just positive 1. So for even numbers, this x negative dissolves and it just becomes x only. So for even numbers over here, see, odd numbers, the x remains. So this is how we do it. Now we can simplify it. We'll multiply the negative sign. So here it'll be x minus x to the power 5 minus 2x to the power 4. Let me just remove this off. And then we have over here plus x to the power 3 plus 6x squared plus 5x plus 10. Now we do again the sign change thing. Let's see over here. Minus to minus, there is no sign change. It remains the same. It's no. But minus to plus, yes, there is a sign change. Plus to plus, no, there is no sign change. No sign change and no sign change. So there is only one. So we will have one negative real root. Now it's very important that you mention it's a real root. See, positive real root, negative real root. Because imaginary roots are something else. We have to write positive real root, negative real root. Now, so what is the maximum number of roots possible over here? It can be only power 5 because 5, right? So maximum there are 5 roots. So it can be maximum 5 and we have 4 positive real roots and 1 negative real root. How many imaginary? 4 plus 1, 5. Already it's done. So there will be 0 imaginary. There can't be. But there is a thing. You can have real imaginary roots as well. So what happens is you can have either 2 imaginary roots or 4 imaginary roots. They will only be in terms of pair of 2. Like 2, 4, 6, even numbers. Why? Because they have to be conjugate, right? They cannot be only plus, only minus. They have to be plus or minus. Now here what we do is, if this is 2, obviously this can't be minus 1, so this will remain same, and over here it will be 2. Okay, and then what can happen? This can be 4, this has to be 1, 0. So these are the possibilities. Now we will look into, this is it. So you can have maximum of 4 real roots, maximum of 1 negative real root, and maximum of 4 imaginary solutions. So that is the thing. We will just look into the, usually that numbers, right, is done from a table. We will see that. Over here you can see, yes, because there was a change from positive to negative, then there's no negative, 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 positive is S, and then yes, yes, yes. So these are the possible roots. Okay, I forgot to write 0 for, yeah, I've written 240, yes. So these are all the positive real roots. And then over here, what about the negative? It was only 1. So it was only 1 negative real 0. And then we make the table. And here these are all the possibilities. You can either have 4, 2, 0 real numbers. But if it's 1, you can't subtract it by 2. If it was 2, it will be 2 and 0. 3 would be 3, 1. But if it is even number, it will go until 0. An imaginary number must be multiple of 2. 0, 2, 4, and so on. So that's how we do these problems. Here we have a check problem. I would highly encourage all of you to solve this problem by yourselves and then continue watching the video. Now I will solve it up over here. For the real positive zeros, it's very simple. The same equation as it is. So here, power 6, 5, 4, 3, 2, 1, and the constant term all are there. So here, from here to here, it will be yes, there is a sign change. Yes, there is a sign change. No, yes, yes, no. Okay, so it's 1, 2, 3, 4 possibilities. 4 positive real 0. So I will just write over here positive real zeros is 4. And what about the negative real 0? It will be f of minus x. So here we will have 3 minus x the whole power 6 minus x the whole power 5 plus 2 times minus x the whole power 4 plus minus x whole cube minus 3 times minus x the whole square plus 13 times minus x, and lastly we have plus 1. And let's solve this up. It will be 3x power x power 6 because it's even power. And here, since it's odd, this minus remains, minus and minus will become plus x power 5. Now here, since it's even, this dissolves, it will be just 2x power 4. And now here we will have minus sign, minus and plus will be minus x cube minus, and this will dissolve, so it is minus 3x squared. And we have minus x times plus 13, so it will be minus 13x. And lastly, it's a constant term 1. Now I have told a few times that you must have all the coefficients. If you're thinking why, now imagine the coefficient over here was missing. Okay, it's going to be 0x squared, isn't it? What is the sign of 0? Is it positive or negative? It's sign neutral, so we have no clue about the sign. So that's the reason why we should have all the terms over here. And now we will have to check for the negative real zeros. So it's plus to plus, no sign change, no again. Yes, there is a sign change over here. Then it is no sign change again. And lastly, there is yes, there are 2 sign changes. So negative, it's 2. And imaginary, what can be there? Imaginary is only conjugates, so it can be the 2, 4, 6, or it can be 0 as well. But now you can see 4 and 2. But over here, this degree is 6. There cannot be 0 imaginary. There has to be minimum of 2 imaginary because, sorry, my bad. It can be 0 imaginary. I thought it was, I counted it wrong. I just messed up the counting. 4 plus 2 is 6. So yes, it will satisfy the condition. It can be 0. But imagine over here it was 2 and 2. Then it would have been 4. And then the imaginary had to be 2. Okay, but since over here 4 and 2, it's 6. It's already done. And then what you can do is start rearranging the terms. I can keep on reducing by 2. So I'll start with the negative. So this can be 4 itself, and this will be 0 now. And what happens to the imaginary? It will be 2. See, because I have to make sure the sum of these roots are always 6. And what about the next one? Okay, the negative roots are done. So I will try with the positive roots. For 4, negative roots are done. So I will do over here 2. And let me try with 2. And 2 is 4. And there must be 2 imaginary roots. And what about this? I will make this 2 and 0 and then 4 here. And it's just like, balancing it out, balancing the numbers. And then over here I can make it 0. So then this must be, let's start with 2, and then there must be 4 here. And then over here I can have 0, and this also can be 0 and 6. So these are all the possibilities. You can have an equation with complete imaginary numbers as well. So that means it just doesn't cross the x-axis. So in the sense, if you have an equation, say since it's even and positive, it'll be opening upwards, and say you have equation like this and it goes up. It never touches the axis. So this is the imaginary roots part of it, because it does not touch the x-axis. So this is how we can solve this problem. We have to just complete the table here. And the table is, okay, they have started with 0, 0, 6. It's fine. 0, 2, 4. And just changing the numbers. Make sure the sum is always the sum 6. When you add any of this row, you must get the sum of 6. Now then, this talks about the conjugate over here, complex conjugate theorem. See, the complex numbers cannot be in one. I told you earlier as well, it will come in a pair, it'll be either plus or minus. It can't be just 7i. It should be plus 7i minus 7i. I is the imaginary number. So here, if you have any term, say now a plus bi, then there must be another, imaginary root, a minus bi. Now what about over here? 1 minus 2i, 1 plus 2i. Both are the zeros. So that is about the imaginary zeros. Now we have an equation over here. Find all the zeros of f of x. Use them to sketch a rough graph. Find all the zeros. And then sketch the rough graph. Okay, that same thing is repeated over here. Now first part, this is a bit lengthy because you need to find all the zeros. You have your calculators. You can directly find it by mode 5.3. But that's not the point. Let's learn how to find it over here. So first, to determine the number of real zeros, what do? So in order to find each zeros, let's understand how many maximum zeros are possible. Since the degree is 3, it's only 3, right? So degree has 3, the function has 3 zeros. It can't be more than that. And determine the type of zeros. That is from Descartes' rule. So let me just do it out over here. Here we have no sign change, yes there is a sign change, and no sign change. So there is only one sign change for positive real roots. And what about negative? So I'll just change it over here. Since it's power 3, it'll be minus x power 3. It'll be plus x squared plus 7x minus 15. There is a sign change over here. Yes, no, yes, there are 2. So you can see there is 2 times sign change from minus to plus, then it's plus only, but again then plus to minus. So that's for negative real roots. So what are the possibilities? You can have a maximum of 1 positive real root, 2 negative real root, and how many imaginary? There can be 2 maximum imaginary roots. Why? Because they're all in conjugate. They cannot be in odd numbers. So here, that's the thing, we just now found it. You can have 2 or 0. Sorry, I forgot to tell, not 2, maximum 2, yes, but it can also be 0 negative real zeros, okay? And then lastly, 2 imaginary numbers. It's not imaginary numbers, it should be zeros because we are finding the solution. They are the zeros, okay? The x-intercepts. Now to determine the real zeros, this is a very lengthy procedure, but I'll tell you some other methods. I would highly encourage you not to do this method because this is just too long and takes a lot of time. There are other easier methods, but I'll just tell you what exactly is done over here. They have done synthetic division. So you can see always the first number will be as it is. That means the coefficient is 1, right? Let's write this coefficient over here. Just write it down over here. So it's 1, 1, minus 7, minus 15. These are the coefficients, isn't it? And now then, here you can see these x values. What are they? They are just assumed. You just assume certain random values and find and divide it. So I will write over here minus 3 and I will do synthetic division. This term comes down, so over here you have 1, and then 1 times minus 3 is negative 3. Add them up, it will be minus 2. It will be positive 6. Add them up, it will be negative 1 times it will be positive 3, and you should have negative 12 as the remainder. So here it's 1 minus 2 minus 1 and negative 12. Same way you need to do the synthetic division, changing this 3 to 2 and 1 and 0. And then wherever the remainder is 0, that is a 0. Why? Because that's a factor. Whenever you have remainder 0, that means it's a solution itself. So that will be that one solution over here. So that is the reason. But now this is just this takes a long amount of time. So there is no need of doing this. What we need to do is we need to take our calculators and try using the table method. Now for this you need to go to mode and go to the table, that is after mode press 7 and type the given equation as it is. Let's look into the equation here. Type it out in your calculator. It's alpha and x cube, so power 3, and then we have plus x squared, so it's just alpha x and square it up. Then we have minus 7 alpha x. Just press alpha and you need to press alpha 1. See, you can see what did I do? I pressed alpha twice, so that's unchecked. It should be checked. And now lastly negative 15, so it's 1 and 5. And now you can just press equal to. This option won't appear in most of the calculators. If it appears, just ignore it, press equal. And now where do you want to start? Now I would generally take it as say minus 5. That would be a reasonable starting point, and then I want to end it at 5, and now the step, let it be 1, and I get the values. See over here, this is what we are doing. So you will directly get the graph. Here it was only remainder, but from this table you understand where exactly the graph is, and you can see here at x is equal to 3 you will have a solution of 0. Why? Because the remainder is 0. Or whichever is very, very, very close to 0, okay? That means just after that, it will be the solution. So that is the thing. And then after that, again, see, it's going up. So that is the details. From this table method, we can easily find which could be the approximate root. So once we find which exactly is a root, so we know 3 is a root. There can be other roots as well, but if we do synthetic division now from x is equal to 3, we get depressed polynomial. That means we understand the remaining terms are 1, 4, 5. So over here, this is a quadratic. It's 1x squared plus 4x plus 5, isn't it? After you solve so much, just put the remaining in the calculator and find it out. I'll show you in the calculator. We can even directly do this x cubed. But if you're right in detail, then all you need to do is use the table method to find which is a solution, and once you find the solution, then the remaining do the synthetic division and find the coefficients. The remaining part over here, 1x squared 4x plus 5 is the factor, right? So we'll just do mode 5 3 and then we will type in the coefficients. 1, there is 4, and lastly we have 5. The solutions for the remaining factors are minus 2i, 2 plus I, minus 2 minus I. So that is the answers over here. You can easily find it out. So this is how we basically find the roots. So we have 3, that is from the table we found out, minus 2 minus I and minus 2 plus I. So this is how we can not easily solve. It takes time to understand, but then you will understand it's a simple method. But it's not over. We have to graph it as well. We know from the equation basic graph can be drawn. If you're getting confused, just you did the table method, right? Just look at some points, plot it out, graph it. Here you should also know what's the end behavior. The end behavior as x tends towards infinity, we right side, y is also infinity, and as x is going towards negative infinity, even the graph is going towards negative infinity. So that's the thing. Now what about this problem? I would highly suggest everyone solve it by yourselves and then check the answers. Now this is again going to be a lengthy one, but I'll try to do it as quickly as possible. And since it's x to the power 4, you cannot use your calculator to directly solve it. Now I will directly jump to the table method, because you know that Descartes' rule, right? How much right, left, and everything. So since they have just told real zeros, I'll directly jump to the table method. So now I'll directly use the table method by pressing more and 7. Let me type out this equation. Alpha x to the power 4, and then we have minus alpha x cube, and last two terms are minus 16x squared. So I'll just press this, and minus 4x minus 80. So that's it, and then press equal to. No need of typing any other equation. I will start it at minus 5. As a thumb rule, I just go with it. You can change the values. And at 5 step, and you can see I got one of the 0 already. It's at minus 4, and that's it. So 1 0 is already found out. It's at minus 4. Now if I do synthetic division here, it will just save a lot of time. I will write the coefficients. It's 1, minus 1, minus 16, minus 4, minus 80. And the root which I got is x is minus 4. So here, when x is minus 4, what do we write exactly? We write it as plus 4. So here, what do we write is the solution, the real root, right? So over here we got minus 4, and now we will just do synthetic division. So the first term comes down as it is. It will be 1. 1 times 4 minus 4 is minus 4. Add it up, it's going to be minus 5 times 4 is minus 20. Sorry, it will be positive 20, and over here we will get. Now here what you need to do is 4 times minus 16 will be negative 16, and minus you need to add them up. It will be 20 minus 20 times over here it will be minus 80, and what happens, sorry, it's minus it's plus. Plus 80 minus 60 is 0. Yes, we have already found that over here. It should be 0, right? Remainder is 0, that means it's a factor. And here this is the quadratic equation. It will be x cubed minus 5x squared plus 4x minus 20. So now since it's cubic, we can easily solve it by mod 5 and 4 for cubic functions, and type in the coefficients. It's 1, and then we have minus 5, and then we have a 4, that is plus 4, and lastly minus 20. So it's 5, 2i minus 2i. So those are the solutions. So I know one was minus 4, we obviously got that. Then there was 5, 2i minus 2i. So this is how we can easily solve it up. Just use table method, then use synthetic division, and then make sure you just put in the calculator and solve it up. Now what about this graph? We have just done the table method, right? So from the table method you can easily plot points. For x value, they'll tell you which y value in the graph, and then just plot it out. Here they have given us a graph, and we have to know which equation does it represent. So we just can't write any equation. We can guess it might be an odd power equation because it's like a cubic function. It might be x power 3 or x power 5 or something like that. But here you can see there are solutions, right? Zeros. What are they? It's 1, over here we have -2 and -4. So it's x is equal to -4, x is equal to -2, x is equal to 1. Let's get them inside. It'll be x plus 4, x plus 2, and x minus 1. Now, in order to find the equation, all you need to do is multiply them. Right? These are the three solutions. Multiply all of them, you will get the equation. So I will do with these two first. It's going to be x squared minus x plus 2x minus 2, and solve it up. It will be x squared plus x minus 2. Now don't forget the other term, it's over here only, x plus 4. Now just multiply them both, x plus 4 here. So it will be x cubed plus x squared. Then we have minus 2x plus 4x squared. So it's like this. I'll just draw the arrows. This with all the 4 terms, and this, 3 terms, and this with all 3 terms. 4x squared plus 4x minus 8. And now we need to simplify it. X cubed plus x squared and x squared becomes 5x squared plus 2x minus 8. So this is the equation. So this is how we can approximate the given equation. You can see here that's the answer. Similarly, please do try this one. Do it by yourself and then check the answer. All you need to do is see the solution over here. It's minus 8. So I'll write the zeros. It'll be x plus 8. Directly I'm going to write it. Then we have over here minus 2. So it'll be x plus 2. And we have x minus 4. You need to multiply them all. I highly doubt this will be the answer. I don't think so. All the terms in the middle cancel off. This is wrong. It's either A or C. And since they are very close, it's either this or this. See, now you do not need to solve it entirely. If you just try to figure out which is the x squared terms, that's enough. So when you multiply all the x, it'll be x's. Then it'll be over here 8x plus 2x minus 4x. So what's it gonna be? It's gonna be 6x. So I think so this is the answer, plus 6x squared. Sorry, I'm just taking the coefficients, but you need to do it properly. The answer is C. So please do multiply this thoroughly, properly in each step, just like we did in the previous problem, and then you'll get the answer. Now we have a real world problem. Here, this is the last problem in this lesson. A book publisher wants to release a special hardcover copy version of several Charles Dickens books. They know that if they charge $5 or $40, their profit will be 0. Graph a polynomial function that could represent the company's profit in thousands of dollars given the price they charge for the book. So now we need to get the equation. Now they have told if these two amounts are charged, their profit will be 0. So imagine this is a graph over here. See, those are the solution points. It's 5, so it should be both in the right side. Only over here it's 5 or 40. Now here, this is the solution. So that's the zeros, right? It is x minus 5, x minus 40. So just multiply these two equations, x minus 5 times x minus 40, and now we will get x squared minus 40x minus 5x. So it's like this. And lastly, minus and minus will be plus. 4 times 5 is 2200. And now we can simplify this x squared minus 45x plus 200. Here, this is the equation. Now look at this. There's a thing over here. Since we are getting plus, how does the graph look? It'll, plus x squared would be like this, opening upwards, isn't it? So do you think this is the maximum over here profit? No, this can't be the case. Why? Because since we are having a real world problem, though that would be the, that is what equation we get, we have to do it logically. the graph would be something like this. Yes, these two are the solution points, but the graph opens up downwards. And so this is what we can get from it, or just graph this equation, but remember, don't graph it downwards, graph it upwards, because here the price is from $5, it increases. That means the profit increases. Obviously, if it is going downwards, the profit would decrease. That wouldn't make sense, right? Over here, say, look, $5, the profit is decreasing. No. So this is the proper graph. And all you need to do is see where you get the maximum profit. You get maximum profit of 300 at if you keep the pricing of around 22.5. So that is how we can solve it up. And if you're thinking how to graph it, just by calculator mode 7, you can easily plot it out and graph it. Just over here, remember, there's one more change I forgot to tell you. You just can't change the first term. You just can't make this minus. You have to multiply the negative sign throughout the equation. So this x squared becomes minus x squared plus 45x, look here, and minus 200. That's an important thing, because yes, you need to just understand it should open up downwards, so it should be minus, but you can't just multiply with one term, right? You have to multiply throughout, and that's what you get. And this is the equation, and you can predict over here the maximum profit would be around 300 for 22.5. So that is how we would solve that problem, and that's the end of this lesson. And that is the end of this lesson. It's a bit lengthy one. Please do try to work out each problems by yourselves. Practice more problems, your practice problems as well. Try to go through them, and if you have any doubts, please do post them in the comments. I'll try to get back to you as soon as possible.